In lesson 4-1, we will be learning about prime factorization. So before we can prime factor a number, we need to talk about what are prime and composite numbers. A prime number is a number in which only can be divided by 1 and itself. So we're going to make a little list here of our prime numbers. We'll start with 2. It can only be divided by 1 and itself, so 1 and 2. The next prime number is 3, and then we're going to skip 4 because 4 can be divided by 2. So the next number is a 5, and then 7, and 8 doesn't work because it's divisible by 2, and 9 doesn't work because it's divisible by 3, 10 doesn't work because it's divisible by 5 and 2, 11 is the next prime number, and then we have 13, and 14, 15, and 16 do not work because they're divisible by numbers that we've already listed. So 17 is another one, and then 19 is another prime number that cannot be divisible or cannot be divided by anything but 1 in itself. So a composite number is a number that is composed of different prime numbers. They can be broken down into different variations of primes, and that's how we are eventually going to figure out a prime factorization of a number. So an example of a prime number would be any even number greater than 2. Any even number greater than 2 is divisible by 2. So 10 would be an example, or 14 is an example. Any number that can be broken down into other prime numbers is an example of a composite number. So the number 21 is an example of a composite because it's created by 3 times 7. 3 times 7 is 21. So the factors for 21 are 1, 3, 7, and 21. So because it's not just 1 and 21, we don't call it prime because 3 and 7 can also go in there. Prime factorization and a factor tree is how we're going to be working with these composite numbers. But again, first and foremost, we need to determine whether a number is prime or composite, and we can go from there. So for some of your homework, you will be determining whether numbers are prime or composite. So the number 63, okay, you'll want to, in your homework, copy the number 63, and then if you can, break that number down by a factor of other than 1 and itself, you'll want to give me at least one example of how that can be done. Checking your rules of divisibility, 2's are any even numbers. Any even numbers can be divided by 2. A 3, you're going to find the sum of the digits, and then the sum is going to be divisible by 3. So for this example, we have 63, so that would be 6 plus 3 equals 9, and 9 is divisible by 3, so therefore 63 can be divided by 3. A 5, divisibility rules are it ends with 0 or 5. And 7s don't really have a rule, so you're going to want to check 7s with your calculator. You can just take a number and divide it by 7. Just so happens in this case, 7 would work. So again, you're going to want to write at least one example to determine if a number is prime or not. So we're going to say here 7 times 9 equals 63, and therefore we're going to call it a composite number. So all of this here should be included in your answer when you're doing your homework. So dotermine whether the number 29 is prime or composite. So we're going to write the number 29, and then we're going to check our rules of divisibility. So does 2 work? Well, this is an odd number, so 2 does not work. Does 3 work? Well, we need to add the digits together. So 2 plus 9 is 11, and 11 is not divisible by 3. Do fives work? Well, this number does not end with a 0 or a 5, so fives don't work. And so we can use a calculator. Well, I know that 7 times 4 is 28, and 7 times 5 is 35, so that's not going to work. So I'm going to go ahead and declare this a prime number, and the only numbers that can go into 29 are 1 and itself. And again, you can just use a calculator and keep checking other primes. You can try 11. Well, 11s typically have a double digit, like 22 and 33 and 44. So I know that that's not going to work. So now we're getting into finding the prime factorization of a number. So if I start with the number 100, okay, and we also talked about before is using factor trees. Well, I want to think about how can I split the number 100 up into prime numbers, prime being the key word. So whenever the number is even, or if it starts with 0 or something like that, I really like to start with 2's and just kind of divide it in half, because that's a number that I can usually do in my head. So 2 times 50 is 100. So again, I'm breaking this down. You can kind of think 2 times 50 is 100. Now, whenever you have a prime number, I always like to circle my prime numbers at the end. So now 50, okay, I can split that in half. So 2 times 25, okay, again, there's my multiplication. 2 times 25 is 50. Again, 2 is a prime number. Now, 2 won't go into 25, but I know that 5 will. So 5 times 5 is 25. And these are both prime numbers. So I'm going to circle both of them. And whenever you get to the bottom, when everything is circled, you know that you're done. Now, what you want to do is rewrite all these numbers as multiplication product. So 2 times 2 times 5 times 5. And we know that if we actually do this, we're going to get 100. But we can write this in another way. We've been working with exponents in prior lessons. We know that 2 times 2 can be written as 2 squared, and 5 times 5 can be written as 5 squared. So the correct way to write this answer is with prime factorization. We say 2 squared times 5 squared. So to make the number 100, you're using 2 2's and 2 5's. So find the prime factorization of 64. You're also going to hear this said as a product of primes. And why it's called the product of primes is because product means multiplication. And what we're doing here is taking all prime numbers. So this would be the product of primes. So if you've seen your homework, it says product of primes. It just means find the prime factorization. So we're going to go ahead and take 64. We're going to break it down. Well, I know that 8 times 8 is 64, so I know some of you might be like, well, can we start with that rather than always starting with 2's? And certainly, you can start like this. Now you want to break down your 8's into 2 times 4, and this is a prime number. Notice I didn't circle anything up here because neither of those are prime numbers. And then 4 can be 2 times 2, and I want to circle both of those. And since I'm kind of done here with all prime numbers, I'm going to go to my other 8. And again, do the same thing. So 2 times 4, and here's a prime number. And then I'm going to split that 4 up into 2 times 2. And again, circle my primes. So I'm going to rewrite that as 2 times 2 times 2. So there's these 3. And then I have 3 more times 2 times 2 times 2. So all in all, 1, 2, 3, 4, 5, 6. I have 2 to the 6th power is another way to express the number 64. So you're kind of wondering maybe now, how do I show my work? Well, everything here is expected for you in homework. You need to show all of that work. Okay, now here's a different word. It says factor. Okay, well, when it says factor, it's a little bit different than prime factorization. So sometimes in your homework, you're going to see the word factor, and when we see a factor, we want to leave it kind of written out a little bit better. I'll show you with this example. So 21 times m squared times n. Well, I want to split up my number. My number can be 3 times 7. And again, both of those are prime, so I'm going to circle them right away. And m squared can be written as m times m And n can be written as just plain n. So when I rewrite this, I'm going to write 3 times 7 times m times m times n. Now, if you look at how we did this problem before, when it says prime factorization, I'm always taking these numbers and I'm combining it and rewriting it with exponents. But when this one says factor, I'm actually going to leave m times m just like this, and I'm not going to write it as m squared. And, you know, that just makes sense, I guess, because here it's m squared, so we don't want to write it the same way. We want to break it apart. So even if we had more factors over here, I would write them all out. So even if I had more than one 3, I would write 3 times 3 times 7 times m times n. So again, that's kind of the difference between the word factor and finding the prime factorization. And that's all we have for examples for today. If you'd like to see more examples, please be sure to check out the online tutors on the Moodle site. You can also check the homework helper that I have linked on the Moodle site for all the odd number problems in the book.